So we know how to calculate the area between two curves. And of course, the question is, what does this apply to in the business world? What is this going to help us evaluate and understand? So an application about this class that I find to be pretty interesting is one called the Gini Index. Has some applications. It was developed by social behavioral scientists, but it has some applications in the business world as well in terms of understanding the market you might be releasing a new product into, looking at where you want to introduce factories or um, other places to develop and produce new products. So let's start with a couple of graphs. One that represents absolute equality and one that represents absolute inequality in terms of income distribution for a country, or we could look at a state, a city, but typically we look at this by country. So this first line that we already have graphed here is the graph of y equals x. This line would represent absolute equality in terms of income distribution. So along the x-axis what we have is essentially the percentage of households, and on the y-axis the percentage of income. So if we looked at this, 40% of households make 40% of the income. If we looked at 80% of the households, we would see that 80% of the households make 80% of the income. So that's what we're talking about with exact equality in income distribution. We can also consider the idea of inequality in income distribution. And if we were talking about absolute inequality in income distribution, that would be basically a curve that was just right on the x-axis. And what we probably actually see is the tail of this in a more realistic setting, even if something was very unequal. Right at the tail here, right as we approached 100% of households, that would jump up to 100% of the income. But basically what we're showing here is that no one in any of these percentages of households basically makes no income. There is no inequality in income, and what we're saying is just the top 1% or top less than 1% of people in a country who earn basically all of the money in that country. So this would be the equation y equals 0. And if we wanted to find the area of this triangle, of this triangular region that we've got sketched out by these two lines, the area of any triangle is always a equals 1/2 times the base times the height. So in this case what we have is 1/2 times a base that is exactly 1 times a height of 1 as well. So that means that the area between these two curves is exactly 1/2. So what we do with the idea of the Gini index, which we'll get to in a second, or income distribution, is we look at the area between two curves. We always start with this line y equals x, which is the representation of exact equality and income distribution. And then we calculate the area between that and some other curve. So this one, y equals 0, is our worst case scenario. So the area between these two curves, the area of the region between those graphs, is exactly 1/2. So when the area bounded by these two lines is 1/2, we're looking at complete inequality of income distribution. So again, that's our worst case scenario. What we would typically see with a graph like this is something added to it called a Lorentz curve. So named by the sociologist who came up with this idea. Lorentz curve represents the distribution in a given country. So this line y equals 0 is our worst case scenario. What we would typically see is something that looks a little bit more like this. So as we get to the top percentage of households, we see that that's where most of the earning is happening. Most of the wealth in a country is owned by the top whatever percent. And then lower income, lower people on the percentage here, lower people on the x-axis are making a smaller percentage of the total income for that country. So this would be some function y equals f of x. So what we're typically interested in calculating is the area, again, between these two curves, where 1/2 is our worst case scenario. That would represent complete inequality. As the area here shrinks, so meaning this area is starting at 1/2, and then as this Lorentz curve gets closer and closer and closer to that line y equals x, as our area decreases to 0, we get closer and closer to absolute equality. So what this idea is giving us, the Lorentz curve, is giving us a way to measure, calculate the amount of income distribution, or how equally or unequally income is distributed across a country, or again, a city, a state, whatever population we were looking at. So we can assign a specific number to this area that we're going to calculate, and we can call that the Gini Index. So we call the Gini Index of this Lorentz curve a single number that helps to describe the distribution of income in that given country. So our Lorentz curve is this curve that represents income distribution in a specific country. Then we're going to complete a specific calculation that gives us something very similar to basically the area between these two curves, which is going to be referred to as the Gini Index. So if y equals f of x is our Lorentz curve, then the Gini Index is equal to 2 times the integral from 0 to 1 of x minus f of x dx. So all we're calculating here, since we're integrating from 0 to 1, the difference between x minus f of x, we're finding the area under this curve, and then we're multiplying that result by 2. So the reason we're multiplying that by 2 is, again, absolute inequality was represented as an area of 1/2. So if we multiply that by 2, then absolute inequality ends up being 1. And that really just comes down to the convenience of interpreting these numbers. So as our Gini index gets closer to 0, it implies absolute equality, or implies that our country is getting closer and closer to economic equality. And as that number gets closer to 1, so it's just easier to interpret between 0 and 1 versus 0 and 1/2. So multiplying by 2 means that absolute inequality would be 1. So as our Gini index gets closer to 1, that's going to imply that our country is getting closer and closer towards economic inequality.